Welcome to David Alexander Maths Tuition. This is chapter 12G on increasing and decreasing functions. Okay, so find the values for x for which the function of x is an increasing function, given that the f of x equals that there. Okay, so what we need to remember is, so this is a quadratic. At this point here, we have the function is decreasing. At this point here, the turning point, it's neither decreasing nor increasing, and on the other side here it is an increasing function. Why is it a decreasing function? Well, that is because the gradient is less than 0. Why is it an increasing function here? That is because the gradient is greater than 0. Why is it neither decreasing nor increasing here? That's because the gradient there is 0. So what we need to do is work out our dy by dx. So dy by dx is going to be 10x plus 3. And for an increasing function, dy by dx is greater than 0. So we need to say 10x plus 3 is greater than 0. Therefore, 10x is greater than negative 3. So therefore, x is greater than minus 3 over 10. So these are the values for x. Anything greater than negative 3 over 10 means that we have an increasing function. Okay, so again, an increasing function means that dy by dx must be greater than 0. So let's differentiate our equation. So dy by dx is going to be minus 4x plus 4. So minus 4x plus 4 needs to be greater than 0. So minus 4x needs to be greater than negative 4. Let's get rid of the negatives. So that means 4x. We need to reverse the inequality though. 4x is less than 4, so x is less than 1. Okay, so again, another increasing function, so therefore dy by dx has to be greater than 0. So let's differentiate this. We've got 3x squared plus 22x plus 7. That needs to be greater than 0. So here we've got a quadratic inequality. So let's make it equal to 0. Let's factorise. I assume it factorises. So factors of 7 are 7 and 1. And that's quite easy just to work out. So x is minus 1/3 and x is negative 7. So all we're doing is we're solving a quadratic inequality. If you don't remember how to do that, then I think it's chapter 3 off the top of my head. So we've got our x-intercepts at negative 1/3 and minus 7. So where is it greater than 0? Well, it's here and here, so that is to the left of negative 7, so therefore x is less than negative 7, and it's to the right of minus 1/3, so that is when x is greater than minus 1/3. Okay, so when x is less than a seventh or greater than negative 1/3, we have an increasing function. Now when it's a decreasing function, dy by dx is less than 0. So let's work out our dy by dx. So that's going to be 14x take away 5. So let's make this less than 0. Let's add 5 to both sides and multiply through by 14. So x is less than 5/14. Okay, here's another one where it's a decreasing function. So remember, dy by dx must be less than 0. So we've got minus 6x plus 2 must be less than 0. So minus 6x must be less than negative 2, which means that positive 6x must be greater than positive 2. So remember, when you're flipping the signs, flip the inequality. So x is greater than 2 over 6. In other words, x is greater than 1/3. So when x is greater than 1/3, we have a decreasing function. Okay, again, another decreasing function. So dy by dx must be less than 0. Let's work out our dy by dx. That is going to be 3x squared minus 14x take away 24. So we need to set this to less than 0. But let's just factorise it. So we've got 3x and x. Factors of 24, I'm going to guess 8 and 3. And if I put the 3 here, that gives me 6. 6 plus 8 gives me the 14. No, that doesn't work. So factors of 24, that when I'm tripling one of the numbers, I'm going to get a 14. Why am I struggling with this? So, well, I could use my quadratic equation solver on the calculator. It's bugging me that I can't factorise and solve this right now. pressure's getting to me. So 24 is 1 and 24, 2 and 12, 3 and 8, 4 and 6, and if I triple one of them, I need to make sure I can get a 14. So if I triple 2, I get 6, that's no good. If I triple the 4, I get 12. No, if I triple the 6, I get 18. Minus 4, there we go, got there in the end. So 6 is going to be there, and 4 is there. Let's just think about that. Positive 4 times negative 6, negative 24. 4x minus 18, x is minus 14. Good, right. So x is minus 4 over 3, and x is positive 6. So it's a quadratic inequality, so let's do a little sketch. So here x is 6, here is minus 4/3, and we're interested when it's less than 0, so we're interested in this part of the line, so that is between minus 4/3 and 6. So I'll put an x between a minus 4/3 and a 6, and just repeat that sign in between. So when x is greater than negative 4/3 but less than 6, we have a decreasing function. Okay, so in this final example, we're trying to prove that a function is always increasing. So if it's always increasing, then that means that dy by dx is always greater than 0. So what is our dy by dx? So dy by dx is going to be 6x squared plus 6x plus 12. So I need to show that this is never negative, that is always positive. So what I'm going to do is I'm going to complete the square to work out the turning point. So I can't complete the square on a 6x squared, only a 1x squared, so that's 6 lots of 1x squared plus 1x plus 2. So that's 6 lots of big bracket, little bracket, x plus 1/2, all squared, minus a quarter plus 2, close brackets, 6, big bracket, x plus 1/2 squared, plus 7 over 4. Multiply through by 6, that's 6 lots of x plus 1/2 squared, so that is going to be 48 over 4, which is, 42 over 4 plus 21 over 2. Okay, so from this I can get the turning point. So the turning point is minus 1/2, 21 over 2. So let's just do a quick sketch. So this is the sketch of the gradient function. So the turning point, so it's a positive x squared, so it's a U-shaped graph, and it turns right at minus 1/2, 21 over 2. So the turning point is, let's say here, doesn't matter that it's not really accurate. So we can see that the turning point is above the x-axis. So the gradient, this is a sketch of the gradient function, it is never negative. So because dy by dx is always greater than 0, therefore that shows that the function is always increasing.